Hello Squids, this is Squeevy here with another YouTube video, and in this video I'm going to be going over how to make a program that solves a maze. Now, what do I mean by program that solves a maze? Well, you'll see, it's pretty much just something that highlights a route to get from one end of the maze to the other end of the maze. And it does that using contours, which is basically, it looks for one continuous line that goes from one end to another. So, there's a specific type of map that this works with. It has to have one line that continuously goes from one end to the other, and more importantly, it has to have an opening and a closing. It can't just be like, a big block with lines in it. I mean, that's not amazing. That won't work. So, this is kind of a basic algorithm. This really just introduces you to the entire concept of continuous issues. Anyways, so basically what we're going to do is this. Where was I? Yeah, okay. This introduces you to the topic of creating maze solving algorithms. This isn't like the most effective one, but it's a start. So, and you'll see it looks pretty cool. Let's start off by importing OpenCV. So we need to have improc, and what's the arrow? No arrow. Hashtag include OpenCV / So we just need to import all our stuff, and I'll show you, what each thing does. Hold on. Hashtag can never forget IOStream. And then, of course, you have to use a namespace. And I'm going to instantly namespace. I'm going to instantly assume you know what a namespace is. I'm assuming you know basic C++. For those who don't know, though, basically just, I'll give you the gist. It's just starting to type. It's just something that sets up. It's just so you don't have to do the CV : thing. That's what it effectively does. Okay, the first thing we need to do is actually create our we need to create our source mat. So a mat is basically just like a geomatrix, but for OpenCV. Don't go around saying, "Oh yeah, it's a geomatrix," because that's not what it is. It's just something that it's like a geomatrix. You know what I mean? It's like one. It's not exactly. So we need to create our source thing, and I already have the path set up. So this is going to be our maze, and let's let's do wait key. Let's make it so it actually pauses, and let's step 01. Alright, step 01, add our image. Alright, so this is going to be our image. Source, we're going to show the source. Okay. Debug. Start debugging, let's run the program. Oh, my cat's on my bed! So cute! I love my kitties. Kitties are the best. I'm the best kitties. The best kitties. Oh, my kitties. Oh my goodness, is this going to take a while? Is this going to take a while? Maybe. Oh, no. Chugging along. We are chugging along. we go, now it's loading. And you should wait a little bit. There we go. This is our image. This is the maze. You can see it's going to start here, and it's going to go like down here or something, or here. You see the opening? This is what it needs. It needs an opening and it needs a close. That's how it knows where to go. Otherwise, it's going to like fill in a whole bunch of random stuff. There's just some prerequisites we need for our image in order for this to work. Okay. Before I do anything, let's make this a bit bigger. Make my template a bit smaller. There we go. So now we can actually see it. Okay, next we need to create our binary image, and this is basically just going to, it's going to convert our image from white and black to, from the walls being black and the background being white to the walls being white and the background being black. And this basically just makes it easier for OpenCV to detect contours. Right, so we're going to do CVT color. We're going to convert it from black and white, or from color to black and white. CV BGR to gray. Okay. And then we're going to make a threshold of binary image. So we're going to threshold or binary image. Now, our binary image. Oh wait. Alright, here's the key thing. You want our binary image to be before anything else, otherwise it's going to show you something really strange and foreign. Step 2. Okay. There we go. Now if we run this. I wish I had a webcam going so I could show you my cats. These are adorable. The first one always takes the longest. There we go. Now we have our binary image. So we have our regular image and our binary image. Just close that out. Okay. Now what we need to do is we need to add in our contours, and so there's a way to draw contours, and there's a way to find contours. If you go to the tutorial where I learned this from, the way they draw contours will give you an error. So I found my own way to draw contours, which doesn't give you errors. Now, before we go on, what is a contour? A contour is basically something that looks for one long continuous line from one area to the next. So it doesn't have breaks from the top of the image to the bottom of the image. And when you look at our image, you see the perimeter reaches the top of the image, then it has that hole, and that line goes from that hole to the end of the hole. So it's just one long continuous image, or one long continuous line. And basically what we're going to do is we're going to look along that line. We're going to make that line a little more suitable for us by, eroding and dilating, or dilating and eroding, so it looks like a wall. It's literally a wall where we have our space, where we have one space and we have the other space. And then what we're going to do is we're going to draw a line for, okay, so basically what we'll have is we'll have, one line and then another line to make that column of the maze, and it's going to subtract this eroded area by this other area, and we're going to get this path that goes along the maze, and that's going to be our path. That is how this algorithm works. So, and this is like a really common thing. Alright, so now what we can do is we can create a vector. A vector of a vector of a point. This is going to be our contours. Okay? Now what we need to do is we need to just find the contours and push it into this vector. So, find contours. Binary image. So it's going to use our binary image. It's going to push it into our contour. Here. So push it into our contours. And we're just going to. This is literally just the thing that. Vector. Start one. Yep. CV. I'm not going to go into much depth. I'm going to be honest, I don't actually know what this method, like all the different documentations for this method is. I mean, I'm a 16-year-old boy just sitting in this room playing this computer, so don't put your bar too high. Alright, and we need to say if we have more or less than our wished number of contours. So if we have like 3 or 4 lines, 3 or 4 pathways, we don't want that. We don't want to do that. It's going to have too many contours. So if we only have 1 contour, then, you know, we have 2 little contours, and we don't want to do that. So we're going to find contours size. If our size is not the sweet spot, which is 2, then I'm just going to return an error. Enough or too many contours. Okay, we're going to do that, and then we're going to return negative. We're just going to exit the program. Okay, so now that we've done that, we can find, we need to draw our contours. We need to create our map for the contours. It's going to draw our contours, this is our map to draw the contours, and then this is just going to be what we use to. And I'm copying this over from my previous project. I did this before, actually. I resolved all the errors, and so you can trust my. You can trust. Step 3. Draw contours. Alright. Now that we've done that, we can start eroding and dilating, and then all the rest of that happy stuff. So, let's create a new mat kernel. This is going to be our eroded, or actually, I'm going to say dilated. This is going to be our dilated. This is going to be our dilated. That's my OCD. No, but actually, I know so this is going to be our dilated wall. So this makes it a literal wall, so you can actually work with it. So we're going to dilate contour image. Contour image. Yeah. Dilate. Oh. We have to have slight variation, or else it's just gonna be like, what am I doing? I don't know what I'm doing, man. Show our wall. Unshow. Step 04. Oh, what is happening? There we go. Now if we run it, you will see a whole new thing. Juicy. Juicy, juicy, juicy. Very juicy. It's so juicy I can taste it in my mouth. Oh, no, okay. Where's the error? First, let's just do this. Oh! Well, there is a bit of a difference. Ah! Oh. There we go. Now if we debug it, we should... Oh, stop debugging. Now we shouldn't get that error, but if we do... if we do, I might have to scratch this video and redo it later. I'll kind of rest it on this moment. Yeah, there we go. Okay, so we can see we've got... Oh, don't worry about that. Get out of here. So we can see we have this image, our binary image. Where's the other one? Okay, and our contour. Oh yeah, our dilated contour image. I don't know what I should into our contour image, but yeah. Oh, I know why. Okay, yeah. So we have our wall. You can see that's a literal wall now, and you can see we found like a long line, and we drew out that line, and we dilated it. So now it's like a big wall, right? So we can use it. Now all we need to do is erode it a little, and then we're pretty much good to go. Okay, first, do this, up here. Okay. Now, we can have our eroded. That, erode. And we're just going to erode. We're going to erode away our image so we can actually use it. Contour image. Delete. Now what we're going to do is do our eroded image. I'm sure. Quick typing, I don't actually have much time left. Step 05. Erode. Okay, now we've done that, we have one last step to do, which is to subtract our eroded image with our contour, so we can actually get our literal path. So all we really need to do is do adds diff contour image erode contour image. Yep. Okay, so this is gonna be our path. This is what it's gonna look like. You'll see what I mean. Just chill. Just chill. Take a chill pill. That's what you need to do. Take a chill pill. Named Bill. Always name your chill pills Bill. Or your pills. Name them Bill. Alright. Now if we debug it. If we don't get any break errors, which is quite common in OpenCV, not sure I quite like the break errors. They make me cringe. Yeah, there we go. Okay, so you can see that. Where's our path? Where'd it go? Wait, where'd it go? Oh. That's a problem. Oh, I supposed to be contour image. Contour image. There we go. Now let's try it. Yep, we're at 20 minutes. Aha! You see here we have our path. You see what I mean? It found a path through our stuff. Okay, so let me go over what happened. We have our regular image. We have our binary image. We have our contours. Yeah, we dilated, and then we eroded. So we have our path, and then we subtracted pretty much this wall, like everything here with everything here, with a little wall in between. We got this. Okay? Now, this is the last and final step. This is very easy. It's so easy. Okay? So we've done this. We've added. This basically just merges our real image, or our starting image, you know, the actual maze that we downloaded from the web, and the contour image or path. So, we start debugging, and you'll see what you get. Pretty awesome. Pretty awesome if I say so myself. Ah, there we go. That is our final product. You can see, it found a path through our maze. There you go. You've written a program to solve the maze. That is how it's done. Thank you all for watching, and as always, I've seen my tutorial, and please don't forget to subscribe, comment, like, all that good junk. And thank you for watching. Au revoir.